Welcome to this video tutorial on xlminer, the data mining add-in for Excel. In this tutorial, we will learn how to use the data reduction and exploration tool available in the xlminer add-in. Data exploration and reduction is used when the data set to be mined is very large and may contain large number of variables that are very correlated or unrelated to the outcome we are working at. Using the tools in xlminer, one can reduce the size of data set or explore the data set to formulate hypotheses that can be worth testing. There are two techniques for this purpose. First is principal component analysis and the second one is cluster analysis. In data exploration reduction, if the data set contains a large number of variables that are correlated or unrelated, what we do is we combine the correlated variables to be represented by one variable and we remove the unrelated variables, and hence we thus reduce the number of variables that are being used for creating the mining model. This helps us to create a easier and more accurate mining model with ease. Let us see how the principal component analysis technique works. The principal component analysis is a mathematical function that is used to transform a number of correlated variables into a smaller number of uncorrelated variables. These uncorrelated variables are called principal components. Thus, we get a data set which has a lesser number of variables, but the variability of the data is maintained since the principal component takes into consideration the maximum amount of variation in data and others after it consider slightly less amounts of variability into account. Let us see how to use the principal component analysis to create a reduced data set. For this, we will use the utilities.xls tool data set that is provided along with the xlminer. We can see that this dataset gives us corporate data on 22 US public utilities. This is the dataset which contains different variables as in x1, x2 so on until x8. Let us see how to use the principal component analysis method in order to reduce the number of variables. We first select xlminer, data reduction and exploration, and then select principal component analysis. Once a new wizard is opened, we can select the input variables and then click on next. Here we can either select to convert them into a fixed number of components, or then we can select the smallest number of components explaining at least x% of variance, wherein x stands for the minimum variance that should be considered in order to choose the variable to be related to another variable. Let us select fixed number of components and then set it to 5. There are two different methods to calculate the variance. One is covariance matrix method and the other is correlated matrix method. Let us select the covariance matrix method and then click on next. Here we select the options which we wish to view in the output and then click on finish. We can see that the xlminer is creating the mining model. Once the output is shown, you can see that it contains a brief summary of the inputs provided to the tool as well as a list of the principal components. Here we can see that out of the 8 input variables, we have converted them into 5 principal components and hence reduced the number of variables that are to be used in our analysis. Here you can also see the scores that have been used to calculate the variance and create the mining model. So this is how we use the principal component analysis to reduce the number of variables in our data set and hence reduce the complexity of creating a mining model. Let us now look at the cluster analysis method. In clustering methods, there are two ways where clustering analysis could be performed. The first one is k-means clustering and the second one is hierarchical clustering. In k-means clustering, a non-hierarchical approach to forming good clusters by specifying the number of clusters, say k, and then assigning each case to one of the k clusters so as to minimize the measure of dispersion within the clusters is used. A very common measure is the sum of distances or the sum of squared Euclidean distances from the mean of each cluster. The problem can be set up as an integer programming problem, but because of solving integer programs with large number of variables is time consuming, clusters are often computed using a fast heuristic method that generally produces good solutions. The k-means algorithm is one such method. K-means training starts with a single cluster with its center as the mean of the data. This cluster is split into two and the means of the new two clusters are iteratively trained. These two clusters are again split and the process continues until the specified number of clusters is obtained. If the specified number of clusters are not a power of 2, then the nearest power of 2 of the above number specified is chosen, and then the least important clusters are removed and the remaining clusters again are iteratively trained to get final clusters. Let us see how to use the k-means clustering tool to create or do clustering analysis. For performing k-means clustering, we will use the wine.xls sample dataset provided to us along with the xlminer. Once the dataset has been selected, we click on Data Reduction Exploration and k-means clustering. Here the wizard asks us to provide the input variables. Let us select all the variables except type as the input variables and then click on next. Here we are to select the parameters of the clustering. The number of clusters specifies the number of final clusters to be formed. This is actually the parameter k in the k-means clustering. The number of clusters should be at least 2 and at the most the number of observations in the data range. Set this value based on your best estimate of how many clusters there will be. It is a good idea to repeat the procedure with several different values of k. Let us choose k here to be 8. We also have to select the number of iterations, which determines how many times the program will start with an initial partition and follow through with the clustering algorithm. The configuration of clusters and how good a job they do of separating the data may differ from one starting partition to another. The program will then go to the specified number of iterations and select the clustering configuration that minimizes the distance measure. Let us select it as the default 10. We then have the options such as fixed start, where xlminer starts building the model with a fixed single starting point. The other option is to select random start, where the algorithm starts at any random point. You can specify the number of starts and xlminer generates as many cluster sets. It decides which is the best one and releases the output generated using best cluster set when we select random starts. Let us select random starts and once we have made the selections, we click on next. Here we can select the options to be viewed in the output. After selecting the options shown above, we click on finish and wait for the xlminer to create the clustering model. We can see that the output has been generated and contains a summary of the inputs provided by us to the tool. We can see here is a random start summary which shows us that as we selected 4 number of starts, the data or the different scores for each of the starts, and it shows us that the third start was the best. We also can see the cluster centers as there are 8 clusters created, and this table shows us the distance between different cluster centers. We can also see a summary of the data where the table shows us the number of observations related to each cluster and the average distance in the cluster. We may also view We can see that the predicted clusters table shows us the distance of every row to the cluster, center of the different clusters. As seen, row 2 has the least distance between cluster 3 and hence is selected to be in cluster 3, whereas fifth row has the least distance in cluster 1 and hence it is selected to belong to cluster 1. This is how the least distance is calculated between the clusters, and then they are accordingly specified to relate to those clusters. This is how the k-means clustering tool creates clusters. We have seen how to create a clustering model using the k-means clustering algorithm. Let us now look at how to create the clustering model using the hierarchical clustering algorithm. In hierarchical clustering, the data are not partitioned into a partition cluster or a particular cluster in a single step. Instead, a series of partitions takes place which may run from a single clustering containing all the objects to n clusters, each containing a single object. Hierarchical cluster is subdivided into agglomerative methods which proceed by series of fusions of the n objects into groups and decisive methods and which separate n objects successively into finer groupings. Let us look at how to use the hierarchical cluster analysis tool. To create the hierarchical cluster, we will use the utilities.xls sample dataset provided to us along with the xlminer. The data provided here is the data of 22 public US utilities. We are interested in forming groups of similar utilities. The objects to be clustered are the utilities. There are 8 measurements on each utility as described. As example where clustering, we would be useful is to study to predict the cost impact of deregulation. To do the requisite analysis, economists would need to build a detailed cost model of the various utilities. It would save a considerable amount of time and effort if we could cluster similar types of utilities, build detailed cost models for just one typical utility in each cluster, and then scale up from these models to estimate results for all utilities. Let us apply the hierarchical clustering model or algorithm to create the clustering model for the utilities dataset. We select xlminer, data reduction and exploration, and then click on hierarchical clustering. Here the wizard provides us with options to select the input variables. Let us select all the variables except utilities name as the input variables and click on next. Here we select the normalized data input and then we can select either one of the clustering methods provided to us. Normalizing the data means subtracting the mean and dividing it by the standard deviation. Is important to ensure that the distance measure accords equal weight to each variable. Without normalization, the variable with the largest scale will dominate the measure. The similarity measure, the option of Euclidean distance, is automatically selected, as we have explained how the hierarchical clustering algorithm works. The other two options are only highlighted when binary data is used. After selecting, we click on next for the final step. Here we select draw dendrogram and show the cluster membership options, where we can select the number of clusters to be shown. Let us select 4 clusters and then click on finish. The xlminer is creating the mining model. In the output we can see that a summary of the input supplied to the tool has been shown, as well as we can view the clustering stages. The clustering stage. In the table clustering stages, we can see the history of the formation of the clusters. In the beginning, each cluster contains only one row, that is, each row is selected as one cluster, and hence we have 21 clusters as we have supplied 21 rows of input data. In the first stage, the rows 10 and 13 are found to be closest than any other of the rows, and hence they are clustered into one set. This is and so on as the process keeps on continuing and different clusters are created. we can select the hierarchical clustering predicted clusters table, which shows us that each of these rows belongs to which of the cluster. We can see how the first, second, third and fourth belong to the cluster 1 and other belong to cluster 3 or cluster 4. This is how they are partitioned into different clusters. We can also view a dendrogram, which is the graphical representation of the 4 clusters. The dendrogram provides a visual representation of the formation of the clusters. The creation of clusters continues until there is only one cluster left. So this is how we create a clustering model using the hierarchical clustering algorithm using xlminer. This concludes our video tutorial on data reduction exploration in xlminer. For more presentations and tutorial videos on data mining, please visit dataminingtools.net. Thank you for watching this presentation.